Hello, welcome to another video. Working through the daytime protocol. So we had been working on a client. Now, you might see in this bottom pane, I'm actually running like a bunch of tests, basically to see how quick it is at different intervals, and to see whether having multiple jobs makes a thing. So this has got multi-forks in it. And I found something kind of interesting. I might open up that to start with. So the interesting thing was pretty much the benefit came after just two forks. And then the rest was sometimes even worse. I have like kind of two versions of this. One was one before doing any, in fact no, ignore me, I'm only showing you these. So yeah, I had some memory leaks, we'll go through that, but pretty much, yeah, it kind of just tails off, doesn't really improve after two things, and I thought that was kind of unusual, and there's a reason for it. What I might do is cancel this, and if we, I don't know, just do this, and do like maybe a bit more. It's kind of weird. My music stopped as I killed that command, but I don't know. It's weird things. I don't know. That's like 10k, so that goes reasonably quickly. Let's go like a million. That will take a bit of time. So if we look at BTOP, we have 15 forks here doing things. Now I've got a few things running. FFmpeg is actually doing quite a bit. It's using up most of my CPUs, golly. So I think I can do per core, and that will kind of show like average over the all 16 cores. But if we go back to this, I think this is more interesting. What we can see is daytime server is like basically 100%. It rarely goes over 100% sometimes. Not sure why. It shouldn't be possible. FFmpeg might be because it does multiple forks and whatnot. And you can see here we've got like 15 clients, and they don't use much memory. Well, they used to use a bit of memory, but I cleaned that up. But you can see here that the bottleneck is actually the server, and I think the reason for that is because it's not multi-forked or anything. But I'm kind of dubious to change it at the moment. So basically the server is written up here, and it uses ePOL, which this is something I've written kind of before I kind of decided to make some videos, but this is it. It does a lot of things. It has like a status bar, and it does all sorts of things, and it handles events, signals. I mean, straight away, even if it's under load, it should quite happily just receive a signal like that. Doesn't do any status before anything hits it, but if I ran this again, it should kind of show that. And one of the things here, the font is actually quite small, but you might see that it's only going up to a certain number of things, like active connections. And that is just 1023 times 15. I will like 102. I meant 1021 before when I said 1023. Just ignore me. But if we do that, we get the exact same number there. 1315315. Sorry, dyslexia maybe. And so that is because we're using select in this. So I think I'll keep the server as it is and see if I can speed up the client, and if not, then I'll probably go back and start the server. The other option is I can kind of show the same steps that I've done with the client, but with a server. So going through a very naive approach of where most of your connections will probably fail because they're not able to be serviced. But yeah. So what I might do first is just look at this diff, because I did actually fix up a few things. So to start with, Arena Free wasn't actually free things. It was kind of like being like, yeah, I'll be in the next free list, but never actually assigning itself. So there was a bit of memory bloat there. I put in some debug lines, but they're commented out. The gist is I wanted to see where the memory was being allocated and how much in each arena type thing. I added an option to Arena New. I actually added a new function, Arena New Clear macro, really, which takes another parameter, which should be a boolean. And if it is truthy, then we will do memset and basically clear the arena if we got it out of the free list. If we got it out of Calc, then it will be cleared by virtue of that. I think I don't really want to have non-clear stuff in here because that doesn't really make sense in my kind of what I'm doing. I always wanted a way to kind of loop over all of the arena, so I chucked that in. So because of this, I've taken away this iodic buffer, but I've kind of put in another one, read buffer, which is basically the same thing. Naming, right? In our buffer, I've added a little paddle, which is like where the free list pointer will be. And I do this because I don't want data to be clobbered. Because data, I kind of want to keep route. Because data in a buffer gets re-out quite a bit. Basically, it's a buffer that can hold as many struct IOVX as you need, and most of the time you only need one. Potentially, I should like find an average capacity, but because of that, our reset buffer no longer does free. It also does freeing of the underlying memory that we pass to the IOVEC. Because another memory leak. Yeah, there was a few memory leaks, and it's kind of funny. Your kernel will do an out-of-memory collection at some point when your memory is super low, but it gets so low that I can't interface with X, so can't connect to X, and like I can't go Control Alt F1 to go into a virtual console. It's like just cool. I'll just let this sit here for maybe 10 minutes, and then the kernel will be like, oh yeah, this process with fucking 16 gigs of memory, I might kill it now, and then it'll kill it. And you hope it doesn't kill Bash, which is the parent, but sometimes it might. So, this does this. And then it frees this back to the buffer arena. But when we get it out, which will probably be, well, we actually put a brand new function, cool. We get a, this is just handle end of file. So this is printing out. I split it into more functions because I wanted to see profiling. I actually did some profiling. What do you call it? gprof, this one. And if we look at, yeah, it'll be something. Let's look at the latest one we did. Cool, that one is not worthwhile, but we can look at this one. Cool, I thought I would have had one that was valid. Cool. Well, we can potentially run some more, but Let's just do this. Oh, like I think I didn't have like a test.c or test.anything else, but what I should have done was test. Yeah, but that's all that. SRMs now. I kind of have backups. Anyhow, so this does a bunch of things. Once we get into file, we want to delete it from our map, so we kind of append it to our linked list, which is our list to delete. Pretty cheap to do that when we have an arena. We still have this view text, which is just to print out to standard output. We can potentially fix this. Just gonna do something, and then yeah. So this is pretty much the same as it was. Reset buffer is it's potentially somewhere up here. I don't know. Oh no, reset buffer was that, but we also have like a fail connection, which is a down here macro, which basically does sets it to be deleted and clears it from the FD set. Whereas this is like a safe one, end of file, so we want that to be a little different. Cool. So in handle select, what have we done? Wasn't actually tallying up things properly, so I've kind of changed the way I've done things. But yeah, you can see here we're basically using IOVEC buffer and read buffer, and we're using it pretty similar. Now we've got a fail connection, which kind of gets rid of a lot of this kind of stuff, and that handle EOF is all of that stuff. Cool. And here we do an arena new clear. So this is that new one that we kind of wanted to do. So this is basically saying, if we don't have a current buffer, make us a new buffer, but don't clear what we had. The reason for that is that buffer might have already done an alloc for space to store its contiguous array of write V's, IOVEX, sorry. And so that means we can kind of just reuse that. It'll clear the size, it'll clear the offsets and all that, but the capacity will still be there, and that means we don't have to allocate memory as much. We're handling the allocation. We put wrappers around it to be kind of safe, but that's that. Append buffer, that's the same. We make sure we free things. We weren't freeing everything before, which ran into issues. Cool, so what's this? This is a bit further down. I put in like debugging, so it's in a separate scope, but basically all it was doing was printing out stuff. It also kind of has some outer stuff, but all I'm wanting to do here was I wasn't passing an arena. Kind of a telltale sign that I wasn't like allocating it right. But yeah, here we also make sure that we break out of this. There was a little bug there. More little debugging. All reasonably straightforward. This one's some more debugging, and this one I had like a bit more information to see the arena sizes and whatnot. Then at the end we kind of say what it does, and the output of this would be in error out. We can see the fork 0 did blah and allocated this many things. Perhaps I should bring this one down to give a bit more information, but it is what it is. Alright, what's changed down here? Not too much. Different arenas. We add in an extra thing to say we can say how many forks we want to do. So this I can potentially even select it. I'd have to look up my keys. I did a cool thing. Or it'll be in my input RC, but yeah, this whole thing here. few things. But yeah, the kill region stuff. It's something that is kind of interesting, but I don't actually want that. I want Man Bash because this one's already defined. Yeah, it was just CXX, and they'll kind of put me there. But if I kind of go here now, then it will like kind of select that, which is kind of cool. I didn't want that, I wanted that one. And from there I can actually delete that. Well, I can yank it. I can yank the 15 if I want, even though I'm like, I don't know, I didn't want to do that, the other key, this one. So I could now go kill, and it kind of kills up to the end of the 15, but now how do I get back? I wanted to do, matey, different keyboards, undo, what was just that? I was trying to do the other one. Anyway, enough of the sidetrack of random film things. So I might redirect Stand It Out, because it is useful to kind of see some things sometimes. So if you don't say how many forks you want to do, I'm kind of defaulting to the number of processes you have -1, which might be a good default. I don't know. At the moment it's not. As I mentioned, we're only really seeing improvement after 2. But perhaps with a better server, that could be a better thing. It kind of makes me want to think maybe I should write a better server now. But I kind of want to write a new server if that's the case, just to show the differences in performance, I guess. So what are we doing here? We actually initialize our map to be a certain capacity. Now, the reason I do this is because like you might only have a certain number of file descriptors ever allowed, so that's like kind of your capacity that you kind of want to put in your map. Still waits a lot of times to do some printing, like 10% of however many it did, I guess. That's another little area of improvement. There's lots of little places you can improve code. It's kind of fine art, I guess. More printf of where we allocate memory and whatnot. There's other tools you can do to do this as well, but sometimes printf debugging is just good. Right, so then we basically do all the forks, then we wait for all the forks. We actually wait for any child now, because I was finding a deadlock that perhaps like one child finished early, but it was the like 15th child, and now you're waiting for the 0th child to finish before you can check any of the others, and wait is still kind of expensive. So now I'm just waiting still the number of forks that I'm expecting, but now I will check that it is a valid fork. So I allocate space to store the number of forks that I'm wanting. And if it's not found, then that's like a weird state that I don't know what the kernel gave me. Cool, and that's pretty much that. We also did some stuff to map. What did I do here? I put in a little free list for the buckets to reduce the number of times I'm allocating the buckets, because each time I was calling out to Calic, if it was like, oh, I need a new bucket, but hey, maybe you might not, there might be a bucket that has been freed up. So basically the map is self-containing all its memory allocation and reuse. rather than free, it will reuse. And what else did I do here? Like a few different things. I don't know. This is code that I didn't really show, but there is a hash map. Where am I? Not on that screen. Cool. So what I might do is check what else I have here. I've got a few things that I potentially want to clean up now. Do something like that. And maybe I'll get rid of these. Is that like a safe one to do? Yeah, that's safe. That's also good. I want this now. Oh, not that. And maybe I'll delete that and what's the one for just everything and the rest? Yeah, all later in the file. Yeah, and I had 3 files. That makes sense. And I now want to do a little test. And because in my get log, I was actually showing little timings. Now, these timings were actually done while I was going full bore with, so if we look at B top again, we're going full bore with FFmpeg. Now that's me just recording a video, but because of that, I want to see whether these are similar, I guess. So what I can do is, and these were like without forking. Like when did I mention fork? Next version forking 15 times. Alright, so I'll do it with the like forking. But yeah, so that was roughly what it was. So maybe we'll get out of that and we'll just do a little client test. So local host and 1313, and how many do I want to do? I want to do 10,000, and we'll do 1, and we'll time that. So it's a bit slower, but that was with 1 thing. But if we do 15, it's about similar. Cool. So what about this 100k with 15 seconds? Is it around 7 to 8 seconds? If it's the case, I'll probably, yeah, cool. And this one, if I yabber for a minute and a half, that's probably what it is. So in that case, I haven't really had any performance improvements, except for the case that I can now get a result for 10 million, which I couldn't before. Because of memory leaks. It would crash. So that's that. And I think I will I'll do this in the background after we get this number, I guess. And we can always amend the commit message. But yeah, minute 13, I actually lost what it was meant to be. Minute 13, maybe slightly quicker, who knows. But yeah, so from that, it's kind of going up by 10 each time, which makes sense. So that's a linear growth. I'm not mistaken. I'm going up by a magnitude of 10. The time is also going up by a magnitude of 10. It's not exponential, which is good. So yeah, I should kick this off, and I would expect it to be, gosh, like 10 minutes, a bit. 10 minutes and what? 100 seconds, so 11 minutes and a half. So a bit. I'm not going to kind of wait around for that, but I'll continue with this. Fix some memory leaks. No timing improvements, but can now do 10 mil. You'll have to take my word on that. So, what do I want to do now? The server or more on the client? Because I mentioned last time there's this thing called poll, which is just better than select. You can get more stuff out of it. But what I'm thinking is, oh yeah, it's chugging. Look at it go. It's like, oh my god, I've got lots of things going on. And I can find out, I've just got this, it's polling on average 500 clients. It's not much, it's pretty busy loop if you ask me. So perhaps I will actually start with a server, which could be kind of interesting. I don't have a server here, and I don't know, running a client's so much fun, but you kind of need the server to do the trick. If you don't have the server, and my one that I've kind of written naively with one blog is hitting the limits. But what I will do is start a new server and try and get up to the baseline that I have at the moment. Perhaps not as good. Maybe I'll just get it up to using select, which I mean it will cope with if it's polling less than 1,000 on average. Though the active count it'll struggle with select there. Yeah, actually, it would be a struggle to. You kind of need to make sure that your active count doesn't go over select. Yeah, I won't do server yet. I'll just work on client, not the binary, the actual source code. And I'll get a compile command, overwrite the binary as it's kind of doing things. It'll be fine. So I think what I'll do is move towards a what do I want to call it? A poll rather than a select. So in handle child, that's kind of where things are doing. But I do an FD set size. FD set size. Where else do I have you? I do have you out in main. So if I'm not doing that, now the question is, what a kind of optimal thing for poll will be, because I don't know. The thing with poll, not that. Kind of weird that got on my thing. So, poll takes a contiguous array of structures that basically have an event and a file descriptor and an event that you're looking for. You pass in the number of contiguous things you have, and you also provide a timeout. So it's kind of similar in essence to the select that I was doing, that you had a timeout and you can kind of say what you want to read, what you want to write, and things in exceptional states. But it kind of groups it into just one structure where event, you basically say that you want it to be in, which is kind of the same as readables, prior, which is kind of the same as exceptionals, and out, which is kind of the same as writables. But you can also ask for RD hup if you have Linux, and you can also get in response a poll error, a hup, or an invalid. So in select, if you have an invalid file descriptor, which is usually a sign of bad coding, I guess, because like you should close it and remove it from things when you know that it's had an error. And yeah, I don't know, but like potentially it could happen. But with this, with poll, you can actually say, it was an error, maybe I should do something with it now. So, how many, this was bucket capacity. Oh, right, so that was just kind of setting the bucket capacity for how many things that we had. What I might do is have where do I want to put some things? It's kind of gross that that's there in a sense, because like the implementation detail of the select is done all the way like in the midst here, and like maybe I just want to get rid of select altogether, and I think, where do you come from? You just come from select, which I would have thought that I need to include this, right? Like important. Weird. Anyhow, what I might do, can we reset? Cool. Do that. So what I might do is kind of just rip it out where it kind of makes sense. So, hold. What I think is potentially like you can either kind of just shove them all in, but you would kind of have to grow it as you so what I'm thinking is I want to have a where's this? Perhaps a define max events and like make up a number. We could potentially do something like 4096. So it's a bit more than what we were doing for select, but like perhaps we could try the same number to start with, but we can change that in a bit. And because of that, now we can we don't have this sort of thing, alright. but we do have struct pole FD. Is that what it was? I wanted that one. Struct pole FD. Yeah, so I basically want an array of these up to a certain size. So we can do something like that, and we can do max events, that sort of thing, and do something like that. What have I done? Cool. And in here we can do like, what was the type that it wanted? It wanted NFDs T's. NFDs T. Is that what I saw? NFDs T. Yeah. NFDs, and this is just going to be events. In fact, we don't really need that there. So this can be that one. So we still do this sort of thing, create it. We don't have this FD set. I think what I want to do here, and actually, did the NFTs specified? Alright, so this doesn't need the +1 type thing here, but perhaps this I want to be for posterity, have something like this. Right, so here I kind of want to make FDs, and we probably need to have like a count. So I guess NFDs T. What did this call it? It just called NFDs. Alright, NFDs, and we can start it off as 0, and we basically chuck it at the end when we're done. But I think I need to have something like this. Bear with me. So here we can have next FDs, and we can go NFDs. Oh no, what do we want? We kind of want terrible name, but we kind of want this, and we want and we'll like swap them back and forth. But nah, we do need a we kind of need a mem copy before we do it. Right, we'll start with just one, because the problem is poll will actually and this can be like, where's my plus? This keyboard is Can I just get away with this? And we'll do sock FD, and we want to do event. Is it just event? It's events. And this was going to be poll in. That is what we care about. And these should be that. That can be that. Right, so we do that sort of thing. We probably still want a map of connection to thing. Right, and then we will we do want that like that. Because we were doing the +1 here. This is going to be that timeout. Timeout was 0 immediately, negative infinite. We can't just do that, but we can get it. Cool. So we do this. That will, instead of doing selected, we now are doing polled. That was poll that did that. So what were we doing here? We wanted to do a for each and handle select, but I think this isn't kind of what we want now. Because that was like in the handle select, we do an is FD set, which we don't have a set anymore. We kind of want to loop over. So here we want to do something like for size ti equals 0, I is less than, and we know it's unsigned now. Hold. And I plus plus. So in this loop, we want to do switch on FD's I dot R events. So that's going to be the return events that we get, and we want to do a little switch thing on that. And this handle select will probably have to alter a little, because really what we want is this part, which is doing a read. So we want to do a handle read, and we also want, oh right, so this is basically saying set it again, which I think in our case we don't need to do. So I think this, what I might do is do a, I don't really want to return because we do have a defer, but we can do a return defer of handle reads and pass it the context, the file descriptor, and the connection, and that thing. If we get all of that, we can yank that, and we can do a handle read. It has a context. In fact, let's not do anything there. Put this in and do something like that. No, take me back there, and no, that one, perfect. Do something like that, and then now we can call that handle read instead of handle select, and then we can just delete that because it's unreachable soon. But yeah, so in here we'll poll it, then we'll switch it, and then here if we have case poll up, and we also need to worry about error, and we also need to worry about poll in val. So in these cases here, do we have that? This could be, but oh no, don't do that, please, Vim. Do that and that. Just looks a bit nicer. Do we have the fail connection here? Not sure we did. Fail connection was up in here, but can we do everything we need? Context is different, I think. Context is not a pointer. Oh, it does this, which is wrong now. Yeah, kind of one. Alright, so let's just write out what the failed connection would look like. So in the, we would also want to care about poll in, and so I guess we might also have this, and we can just say unhandled event. And like, do we just give it the number? D for do something like that, and then we can just pass it the FDs by and FDs. Well, actually, I want but here I want our event, and here is the file descriptor. And I think I want to go requested that, and then we can go fds I dot events and put something there. Cool, so that's like the raw basics of it. So if we have this, we kind of want to do the handle read that we kind of made, and do we have a context? We do have a context there, but it's something like that. And what else did we want to past to it does handle. Oh, come on, but that was T marks actually. Where do we get the connection from? Connection. That's just passed in as part of the map. I've got it. Alright, so we're looping all over wherever it was. We were looping all over the map. So at this point here, we also kind of want to I mean, that's what it is, but do something like that. I kind of want to do something like that. And maybe if our events are equal to 0, we want to continue. It's just what we want to do. So in this case here, we want to get the connection. So connection T, which is connection, and we want to get like map get. We don't currently have that, but I believe I do have it. Map get. So we do have a map get. So we map get the map. So what is it? It's C map. We want to get the key, which is going to be file descriptor. We want to set it to a variable, which is going to be connection, and we want to have a error case. Take me back. Oh my god, you lost me. Cool. So in the error condition, I kind of want to go unreachable, because if the map, because it should be. But do I like, well, the fail connection, we maybe want to make sure that it does that. Right, so at this point here, we have our connection. What do we need that connection for? And the handle, well, if I just search for this bad boy. Right, so we pass it the file descriptor as well, and also the connection. I kind of want to do this just out of that. I also kind of want to we need that. Yeah, that's making it happier. Right, cool. Get rid of get me rid of that. Cool. So we want to do this, but it's I think if this what do you return? You do this exit failure. Cool, so if it was -1, then we probably want to do defer return. No, return defer. It started raining. Right. And we probably want to say that was an exit failure, which is similar to this here. Right, so that's what happens on input. And really all of these cases are like failed connection. So failed connection, we potentially should pass it the context. Oh no. No, do it there. We won't be doing that. It's starting to rain. I think it will be a bit more clear if we pass that in, because that's kind of what we need to know. I think that's roughly what we do. I mean, really, what needs happening is we don't really need this node business. We just need to know that it failed. And then we should deal with that. Because if it failed, we kind of want to tell Poll not to care about it. So like in these cases, this failed connection should be basically getting something like this. But we will we do need like 2 copies of this. I think you can do like some cooler things there. So what we would want to do here is kind of do both of them. Yeah, I think both of them, but then we want to do NFDs plus plus. So we kind of have 2 sets with the same information in. And then when we poll, we don't really want to touch the one that we are currently looking at. So we have this current. And then I guess before we do the poll, we like do a mem copy. Yeah, I guess we do have to do a mem copy. So we'll do a mem copy into I kind of want to call this current and next, like that. That one. And then we'll just only put it into next. And then we'll copy into current whatever next is NFTs times size of struct poll FD, something like that. And then we'll just do it on current. But now next is what it was, and then we can kind of just remove stuff from next. I think that's roughly what I want to do. So in here, a failure has happened, so we kind of want to go next NFDs. Well, we want to get the thing where we are currently, and we want to say well, do we need it? No, I think we can get away with current. We can get away with FDs. Just the one. Do I still have that? Next, that's what I called it up here. FDs. Sorry, going a bit back and forth, you know. I'm liking how the rain stopped. I think my heater has gone off there, so I might tap that back on. Cool. So we do this, and then we, on error, which is down here, we will FD's I is going to be equal to FD's of NF, or maybe minus it here. I mean, I can do something like that. And we basically get what it was at the end and basically shrink the size down. And then next time we'll be using NFDs, but at the moment we're only going up to polled. Now, I think we also kind of want to loop again on the same index, because now we're kind of saying take the last one. Alright, so now it doesn't really need that continue. Doesn't need that break. Take the last one, put it in place of where we are, but we haven't actually looked at this last one yet, so we should probably look at it. Because of that, we also maybe need to do a little check here. If I is greater than NF, well, we want it to be less than both. I think potentially that is looking about right. So in this case, we actually want to do the map remove thing down here. So we would remove from the map the file descriptor, which I believe we copied. We have the connection. This is that. We remove from the map. What else do we need to do? We need to free the arena, free the connection. And maybe do this removed plus plus. So now we don't have any of this. We do have that. This we need to, I don't know where it took me there. I wanted to go here. And then here we don't have anything to delete anymore. It got done in here. And so I guess in this case we also want to do this. Yeah, because that's still doing that. So I think I want to just do that continue there. But if it was fine, then we doing it fine. Cool. So I think that is roughly that. So see what happens. Here, what do we want? We wanted to give it the context like that, and we also wanted to give it the file descriptor. Where did that come from? Came from there. So we don't really need this. So I might just do that. I see what I've done here as well. Cool. So that was in this one. So I guess here we need to have an int rect equals 0, and we probably also need to have a defer return rect. Now, does that mean that we actually have any thing to clean up? Oh well, I'll just keep it like that. Right, so we don't have last. I think this is in the context. Where was it set? Yeah, it was kind of. We kind of want to do this and something like that, and do something like that. So we need whatever poll needs. Poll.h, cool. Right, so it needs to know that this is a struct poll fd. It's kind of weird. I don't know why it can't work it out. Right, so readables we kind of need to get rid of in a few places. So in handle EOF, I think we want to do something like that, and then handle child is now doing a handle read, and in handle read we have a handle EOF, but in handle reads I think I want to do this. Something like this, and do that. Case do nothing there. And maybe I'll actually have a thing there. So this was, was that was destined to continue. And that one isn't, but if we have a case 1, so in this case we just do a break, and maybe I'll do that on a separate line. So in this case we want to do that. So we're kind of like untangling the cases where we were doing that outside, and potentially this could be doing it, but like FDs isn't in the context, so we'd have to just add that to the context. Right, so handle rec. That is because of that. It's like a weird cryptic error that I'm always like, what does that mean? but yeah, we need to do that and do that. Huh. So maybe we'll do this and defer one. Yeah, it's kind of weird. So handle EOF. Yeah, something like that. And then in here we would do that. So that compiled. So what I might do is maybe it didn't do them all, so it's meant to word count like everything, and it's not getting them all. Sometimes gets hardly any. Right, so I think what I need to do is actually maybe just get 10 and just the one things, and try and see why it's not printing everything. So what I might do is bring out this one, and here we can not that one. So here we can change that to hold. Cool, so it's only in a thing. So here we can so what's happening here? It's only polled once, so like it polled 4 things and it did them, and then it decided. That was it for me. Oh, I hate things like this because why is it not from here? Not from here. From here. Last might not be getting set. Do we care about last? Perhaps we do care about last. I think this want to do that. Didn't do as many. Didn't do them all. I mean, alright, so I guess we need to go and do the old GDB. So handle child, break on that. So now if we run this and get to here, so we add this little thing. I might do a display on FDs. Yeah, and it will tell me a few things. Cool. And I'll also do a display on NFDs. And perhaps I'll also do a display on C last ID, and also C count, just so we know. Or that's because we just want to do that display 4, I guess. Alright, so we're in the loop because a last ID is less than count. We do all that stuff. So now in here we should be kind of creating sockets. So what I kind of want to do is see how many we do. So maybe I'll do a display on created. And I kind of want to do a break on child.c, client.c, and 391, that will do me. So now I can just do a continue, and we created 10. So we've created all 10. This potentially might just work because I've run through it slowly. So perhaps I can do a break on for a 1 instead. And maybe do a display on hold. So you can see here, FDs has like a bunch of stuff in it, and we can see there's like R events has 1 in a lot of places, but we also have that. But we also have 10 things, and it looks like we have input from them all. What I'm going to do is run this and continue from there and break unbreak delete break point and 2. That's where we've kind of end up. So now if I continue, we have just got to the polled. So polled, I thought I did a display on polled. Polled. So we only got 7. Perfect. This is what I want, because now I kind of want to see like why didn't it go all the way. So maybe we'll look at removed and also I. Yeah, you've got I now. I was a thing, which I wonder if that kind of matters. Right, so we do this. We do a read. Perfect. What's our rec? We should be removing it from the map. Perfect. So that should remove from the map and do that. Now, what I'm wanting to see here is NFDs is 10, so it should be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 is this one, but we want to get the one before it, so this FD equals 12, and we basically want to put it where we're currently looking. So now I is negative, that's just what it is, and now we can see here 12 is at the start. And did 12? I can't. And now we've removed 1. And when we break, we don't want to break, do we? Yeah, we don't want to break there. That's why we're potentially losing some. Continue. That one there, thanks. So it still only does the one. So where was it that we wanted to break? Perhaps there. break at client.c on 423, and if we run this, go here, right. So what do we want to display? We can probably display our FDs. We probably want to see how many we have. We probably want to see how many we polled. And perhaps we can see how many we created. That one. And perhaps we can also see how many we have removed, and we can have a look at I as well. So this is kind of the current state of play. So here we should kind of do the same. We handle that. We printed out a thing, cool. And we only polled 7, that's good. Now we remove it from the map. We free up the connection. We put 12 at the start, perfect, and 12 didn't have any R events before. We say we're not displaying I, but yeah, it's negative. We have now removed 1. We're back to 1, but now we're looking at 12. There was nothing on it, so maybe we could do like a little something like this. So this one's got something. Number 4. And that is also kind of doing things. So now that kind of pulled in 5 instead. Yeah, so we pulled in 5 in that place. Oh no, that wasn't quite right, was it? I'll start from the start, which kind of makes things a little funny. So we have 3, 4, 5, 6, 7. It goes up in order, perfect. So we do 3. So after, perhaps I want to do a break at this point. So we should do 3, and it should swap with 12. Now we should do 4, perfect, and we should swap with 11. We didn't. So perhaps start from here, and I need to get the end of this loop, I guess. We can also break on client.c for 80. Cool, so now we can kind of see what is happening. We can do 3, perfect. So 3 will swap with 12, perfect. 4 looks good. 4 should swap with 11. And after 4, I would expect to do 5, right? And we're at the same point, and it's swap with 5, right? So 5's there. Now I would swap with 10 after draining it, perfect. 6 is there. I would expect 9 to be swapped. 7, alright, now I would expect 8 to be swapped in place. Now it's on 8, but this is kind of like the last one. So 4 is there. The next time around it will be 5, and it will be over the NFTs. That kind of makes sense. So here we should kind of do the handle read, and we should remove something. So this will swap the 8 with nothing, I guess. Because, yeah, the index will be the same. So it'll just swap 8 with itself. But it will kind of reduce NFTs down. Perhaps I should clear out the other one, which could be a bit more useful, but now we basically have 4, so we've removed 6, basically done 6, and we should have 4 left. 0, 1, 2, 3. So we basically have those 3 left in the queue. I is 3 here. Should skip over. Perfect. And what does this look like? Our map has size 4, so we've still got 4 things in the map. Print out a bunch of stuff and it has to kind of look through everything. Right, so at this point here, I think this is where it's not liking things. So if we look at P, C last ID, and then P, C count, and P NFDs. So we had some NFDs, so we should be going into the loop. Perfect. Do we add more? Apparently we are adding more. But now this will break, yeah. And I think the last ID will be 12. So it kind of increments over. But there's almost a race condition that it just keeps on adding, overflows, comes back around, and you're like, cool, I'll add more. Maybe I'll just put in a little thing there. I think that's probably good. Anyhow, so what do we do here? It broke out of something. Let's start again. So we should do 8 things. So like maybe C8. Perfect. So this should print all the things. Cool. So when we're back up here, we should still have 2 things in the bucket. That's cool. So if last P last, yeah, we don't care about this last equal 0. I think I want to do that instead. Does that have 10? That looks like it's kind of got 10. It's out of order, so it's hard to tell. Now that if print f this whole one, that, yeah, and then get rid of that. Thanks. Cool. So now we do this. So is that a little quicker? 10k was 0.8 seconds. It's like maybe a little slower, in fact. 0.4 seconds? Oh, couldn't connect, but interesting. I might restart that. Did all 1,000, perfect. If I do 100,000, why can't we connect? Server saw 237. We only responded with 92. So I mean that message could not connect is not really what we want. Is actually something like that. Too many open files. Perfect. I thought that might be the case. So if that is the case, I think we want to just save this. So this is a M file. We can see what it does. M file. So is it when we do it on socket though? Yeah, it's probably on socket. Yeah, so on socket we can get EM file or EN file. So M file is just number of file descriptors I'm allowed, which defaults. Where are we? Something like this. And then if basically if we hit that particular error, then we don't care. Oh, it still does it. Oh yeah, I suppose we need to do it here. Still got the error number. Something like this. Cool. So now it's doing a thing. Perfect. Hasn't got them all. Fun times. So if we did 10,000, did we get all 10,000? If we did this many, how many do we get? And U limit minus N. So that's the number of files we're allowed to open. We can kind of extend this. So if we look at the max we can do, it's this, but I kind of want to get this dynamically, I guess. And you can get this with minus K R limit, something like this. Yeah, so we can get R limit, I guess. We don't want to vim it. So if we man it, cool. So at this point here, I think when we hit main, we kind of want to raise that up. If we can, if that makes sense. And only if we should. So I think what I want to do is, so we have a struct limit. So if we get limit, so what is the resource that we need to kind of give? File, I believe it is. Value 1 greater than number of files. Yep. Oh, we can also get the in-proc limit, which for you limit in-proc would be like this one minus u. So theoretically we can have that many forks. Not sure it will help though. But yeah, so in here we have our limit no file, our limit no file, and pass it to this limit. And I am assuming that return is -1. So if this is equal to -1, then we can do a p error. Get limit. There was an error, and we can do a return defer exit failure. Perfect. So at this point here, we kind of want to check the count. So no file. 1 greater than the maximum number. So we get it in this two things. So we can get limit dot lim lim current, which is the soft limit. If this is less than the count, then I kind of want to and we kind of have like 3 standard input, output, whatever. There could be more files open, but it's a rough sort of thing. Right, so if this is the case, then I kind of want to go rlim cur equals limit dot rlim max, something like that, and take me there. And then I want to do a set limit, which I assume is kind of just the same. So now we want to set our limit no file, and we can pass in that same limit object, but we've now modified it. So now we can do this, and perhaps these can be like that, and that could have just been like that. So at this point here, we have now got enough capacity to kind of get it, but now we need to include sys-resource .h potentially could. Cool. So now we should have a limit that will allow us to basically get that. Now we get a different thing because now it's like, whoa, buddy, you've gone over that. So we can have a look at that. So here we have this. Where else do I use it? I want to make sure that like, do I want to say that this is max events here, maybe? I don't know if that's what I want either. No, because now we're saying not many. I think that's potentially what I want. Hey, that's not what I want. Let's just do this with one thing. Well, like one's fine, but multiple, we get some errors. And we got all 1,000. I'm kind of glad. It's good to see that concurrency stuff works sometimes. Right, so what do we kind of crap out on? Stack buffer overflow. Classic. Alright, whereabouts are we? 383. This is, we're trying to overwrite NFDs. So I guess this, we don't want to go over NFDs. So perhaps this we want to be like that. I don't know. Maybe I want to just do something like that. Looks a little gross, but yeah, this should work. Get all 100,000. How good were we with this? What are we doing? 100k. It was like 7 to 8 seconds before. But that was with 15 cores, which, wait, look at that. Doesn't care about that anymore. The server's got in a weird state. It thought it had a few things. Probably because we connected, but then just dropped it. So if we did this, 7 to 8 seconds, I reckon this max events we can jump up, because at the moment it's going slower. But if we make max events something like, I don't know, 4096, we kind of want to see how many we poll on average. Perhaps this is the way. It will print out a bunch of things. Or it won't print out anything. I would have expected oh yeah, I see. It's like So it's making 4,000 connections. I believe that's what it's doing up front. Going slow. I like how it's like little colourful. Yeah, so now after it allocated a bunch of stuff, it does some things. So if we have a little look-see at this, how much was that? That was like a bit much. What I might do is maybe break it down to just 2 and I'll just output it to a file. And it was taking a lot longer. It's doing a lot more printing now. Yeah, so that's like 7-8 seconds. Perfect. So if we have a look at this air out, what do I want to see? I basically want to see the polled. It's like in the thousands. So do we ever polled space star 2? No, what do I want? I want something like polled space 2 at that point. Right, so we get a few over 2,000. Do we have any over 3,000? No. Do we expect any over 3,000? It would. So we could go higher, but perhaps the limit is in the server. I don't know. It's kind of a bit interesting. If we run that again, I'm kind of interested. So server is polling on average like 1,000, but then it goes down to like 455, I reckons. Yeah, I'm not sure how much I trust the average after it finishes, but it was polling around 1,000, which could potentially mean that this is too big. Yeah, it's kind of hard to know because it hasn't really made a difference. And what are we looking at? And we can do this now, which is what? Make sure it's right. 10 million. I just want to kind of see memory and stuff. Memory and stuff is looking good. Polling on averages. I kind of want to start it again and run that again. So polling on average is like only 600-ish. So this is like we reduced it a little. We're getting an active max of like 4,000. So we got 2 threads, which is probably expectable. So I think we potentially could have more. Is that what it is? 3072. It's kind of hard to know without the optimal server as well. Because as I said at the start, and as you can see in the B-top, the server is 100%. It's just churning. In fact, I think there's like not enough work going on at the moment. Um, Alright, minute 20. What was I saying? For 10 mil, I probably said it was something, but it's kind of... can't really tell if we've made an improvement. I can't recall what it was before. But if we do a search on this, it was 15. No, we control C that. Yeah, we don't have it in the buffer anymore. Guts. There goes me saying that I was gonna do it. Anyhow, what we can do is do a get stash. And do another make and stash hop. Yeah, I wonder whether the server needs a overhaul. I wonder. I can also start profiling this as well. See if that makes a difference. Could be an interesting little exercise to go through. I'll wait the minute or so it was. Oh, this is just 1 mil. We do have that one. The 1 mil was a minute 20. So yeah, we are like around that. And that was using select. So I wonder if at this point it really just needs a better server. Hard to know. Because, yeah, at the moment, like, it's got active of, like, 20,000 connections, but it's polling on average only, like, 500. But if you had, like, multiple threads going there, you potentially could churn through that a bit better. Anyway, what have we done? We basically have set it to polls. So the FD set, I saw there was still another one for read set. So maybe I'll get rid of that. What's happened here? That looks good. And we're still printing out, which I've just been saying no to everything, I just realised. So what I want to do is actually just get add minus p everything. Cool. Cool. So this is move to poll. No difference. Really. Bottleneck on server. Cool. So I think that is maybe that. And like what I could do is try and make this like quite large. It's a lot of things on the stack, and we can just see if that makes it any better from the 120. And yeah, hard to know. What I might do is just reset the server. Maybe bring up a little B top. So we're going hard, 20 things, lovely colour. The server's not actually showing up here. We're currently churning, making the connections, and then now the server is kicking in because the server's making the connections, though the client still has more connections to make. But yeah, the server's not actually doing much at the moment. Which, yeah, not sure what that means. I guess we do have 20, which seems like a little ridiculous. Hard to know. Oh, look at that. That was heaps quicker. Down from like 120 to 1. We'll see if it's the same all the time. So it could be that we actually tweak this even more. Though, what is it polling on average? Polling on average 10. What I might do is restart the server again. Ugh. Because it seems like if it's going quicker, the server should be polling more, I guess, than the 500 on average it was. Still just connecting. Alright, so now it's polling on average 9. And it's already said it's got like a lot of failed connections, like 41,000 failed connections. And that's potentially I've connected too many. And I actually wonder whether, the minute it returned 0. So it basically made a lot of connections. They all failed and they all timed out. So there is an upper limit that you want for this. Basically, you only want it to go as fast as much as how much you can process in a reasonable-ish time. So I guess like 4096 maybe is the winner. Yeah, we got even more failed ones there. The server does have stuff outside here. I'm aware that you might not be able to see everything, but yeah, it's currently polling on average 2. And it's failed 92,000 connections. So that's when the server tries to send it, but it gets a e-pipe or something. Like, basically, we've connected too quickly and can't read. It's taking a lot longer to get that minute now as well. Taking a bit. It was like a minute before it came back with nothing, but I don't know. Because what I want to do is I don't know, switch it back to 4096 and maybe keep that there. What is we could keep it smack bang in the middle. Yeah, 3 minutes to. I mean, that was getting some stuff back, whereas the other one failed a bit quicker. So I might restart that. Just it resets the error count. Ideally, you don't see any errors in the server, because that means that a client was too slow. It was too slow in getting a response back to it, which could mean that the client's too slow connecting. Could mean all sorts of things. Alright, we're already seeing failings. Yeah, so that's already too big. So if we just have the 4K, really responsive for -9 of the first process, yeah, and that should do the trick. I just want to, yeah, that did kill it. We've also got 20 threads. I think I want to make that just the 2 threads, because we know that between 2 threads might be where it's at. Polling on average like 1,000 there. So I wonder whether the 10K there would be better. And this isn't failing any. What was it? Minute 20 was what we kind of want. Feels a bit slower. Nearly there. And it's getting all of them. Yeah, cool. So if we go with the large amount, but just for 2 threads, I wonder if that will kind of do it. What I want to do is just restart the server again. Polling on average still 1,000. So I think with not too many threads is the winner. But the server could definitely maybe have another fork or something. It's kind of interesting because if you do the forking model on the server end, the listening socket will be the same throughout all the forks if you bind before you fork, and that way you can actually listen on that in all of them and only get working. Well, like you basically have your own connection pool inside of every one, but yeah, I don't know. What did I see up here before? Readables, FD set. Yeah, I still had one up there. Cool. So we can actually have a largish number. Um, and just the two threads. And I think we're like kind of hitting the thing. Can you hear why? Heaps. You can only put too much on your stack, otherwise your stack will like have some errors. Oh, this maybe looks better. I might just restart that. Hard to know. Yeah, it's kind of interesting. We're basically gone from a select model to a poll model, but the bottleneck is on the server, so we're not actually seeing that benefit from using the poll. There is also e-poll, which is the next step up that I was going to go to, but because we're hitting the server, I think the next episode will be focusing on a server from the ground up, similar style to the client that we did. I'll probably start with just as like a single threaded, like accept the connection, send a date, accept connection, like just a loop like that, pretty tight. Get performance with the current clients based on that, see any increases, decreases compared to what we currently have, and then from there we can improve the server, hopefully see the results come down from our current client until the point we will hit like a new kind of bottleneck, at which point then I will probably go back to the client and improve that, make use of. There's a couple of steps left on the ladder of like high speed stuff. So there's like e-poll, which is a similar task to poll, blah blah blah, but you can do a few different things with that. You can do edge triggered rather than level triggered. I'll get into what that means when I start talking about it. But you also have IOU ring or something. IOU ring. Linux. Can't remember what it is, but it's specific to this. It is IO_U ring, maybe. This. No, we don't have a man page. But you had a interesting that. Interesting, I don't have that man page. But yeah, this one is a little different. But from what I get, it is quite a bit. Right, so I need to get a library to use a kernel syscall. Is that what I'm kind of seeing here? Because, yeah, these are all syscalls. I don't know, like, maybe I just do it myself and not have that library. Do it raw. Anyhow, those are the kind of two options. That was really slow and it failed. So, that tells me that that was too much of a change. So this should hopefully now just get the 1,000. Yeah, the server is really quick to respond at that point. Like we're not over connecting, I guess. Perhaps this could get improved at another point, because I also wonder now whether the response time is a little slower. So if we kind of just do a little test with netcat, so it does creep over a second. That does the what we want is bash minus c of that, yeah. So we want to do like that whole thing. So that, yeah, they'll do me what I want. So yeah, we're like around a second. This should finish now, and now we're almost 0.1 of a second. Like maybe around 0.10 of a second, but like it's a lot quicker once there's no load. Significantly quicker. So yeah, need to do some things. Anyhow, I think I might maybe just amend that to the last one. What did I say the 10 mil was? I might run the 10 mil. I don't know. Yeah, I think from here I will start work on a server. It's probably the right step to go. I might bring this back there. I might just kill it. Can generate a new one. Cool. So thank you very much for watching this. I should probably push this up somewhere at some point. I've got a Git repo, but I haven't published the Git repo anywhere apart from my laptop. But and backups. But perhaps next time, once I have a server, I'll do that. Until then, thank you very much for coming along and watching, and I hope you enjoyed, and until next time, see ya.